Hello, in this video I'm going to teach you about electric circuits. And before I teach you about electric circuits, I have to teach you a little bit about electricity. So let's start there. I need to remind you what the universe is made of. Everything in the universe, pretty much, is made of atoms. And atoms are structured where you have a nucleus, a part in the middle of the atom, where all the positive charges hang out, the protons, and then you have the electrons outside. They don't really orbit like they do in this picture, but this is a good way to think of it, where you have a big positively charged nucleus in the middle, and then a bunch of small negative electrons swarming around. That's right-ish, that's right enough for this class. And this is a simplified version of it. You have a positive charge in the middle, and a negative charge circling around it. So it turns out that the nucleus of an atom is heavy enough that electric fields don't move it very much. So if I put this in an electric field, it won't do very much. What will happen actually is the electron will get pulled that way, because you remember electrons move in the opposite directions of the field lines. So the electron is going to be pulled one way, the nucleus is going to be pulled the other way, and then these two are going to be pulled together because they're positive and negative. So you end up with this tug-of-war situation, and nothing ends up moving. If you have a lot of atoms in a row and you put it in an electric field, though, something different happens. In this particular case, these electrons, if they're not held very tightly, can start moving around and pass from one atom to the other. So the electron, it'll start on this atom, but it moves because of the electric field all the way through. And this continues as long as there are different atoms for it to be passed to. So you end up with this, it's not a tug-of-war, it's like hot potato, right? They're all passing the electrons in one direction. Because these electrons actually have mass, like they're heavy, and they move, they have kinetic energy. 1/2 mv squared, right? They have a mass and a velocity, so they have kinetic energy. And if they have kinetic energy, we can take it and turn it into other forms of energy, like light, for example, or heat. We could turn it into the motion of a fan. This is how your air conditioner works. Or, we can power a refrigerator. The motion of these electrons has energy. And so we can take that out and do things like, power your house. This is all electricity is. Electricity is the movement of electrons from one place to another place. They move because of an electric field that they feel. So the negatively charged electrons feel an electric field, and then they feel a force as a result of that. And if there are the right kinds of atoms, they can sort of slide along a path, like a highway. And we utilize this motion. We take energy out of it and use it to power everything. So electricity is just electrons moving from atom to atom. So now that you know what electricity is, I want to tell you about resistance. And resistance is a really important part of understanding electrical circuits. Normally, you have an electron, you put it in a field, and because it's negatively charged, it moves in the opposite direction the field tells it to. So if you put this electron in a leftward-facing field, it'll move to the right. Electrons move when they're exposed to electric fields. They don't move easily through all materials, though. Here at the top, I have an electron that's just floating in outer space, not bound to anything in particular. And then on the bottom, I have an electron in a wire. Maybe it's made of copper or silver or something. If I apply the same electric field to both of them, they're both going to want to move in the opposite direction. That's the force they feel. But the electron in outer space, without moving through any particular material, is going to go faster than the one that's moving through something. It's not weighed down. Like imagine you were trying to sprint 100 meters. It would be easier to sprint on a field than it would be to sprint through a swamp, because you have to run through the water. It slows you down. The resistance of a certain material quantifies how difficult it is for electrons to move through it. If something has high resistance, that means that it's hard for electrons to pass through, but if it has low resistance, then it's easy. So a high resistance would be like trying to run through a swamp, and low resistance would be like trying to run through, a track. So I have two different materials, two different wires. The one on top has low resistance, and the one on bottom has high resistance. If I apply the same electric field to both of them, which one do you think is going to move more easily? Well, the electron is going to move more easily through the low resistance material, and it's going to be harder for it to move through the high resistance material. So the low resistance wire will let the electrons pass through more quickly than the high resistance one. That's the difference. Resistance basically just measures how difficult it is for an electron to move through something. Finally, this is circuits. I got to talk about circuit symbols. This is a sort of shorthand that people use to represent real-world situations. Like what I have here is a battery, 2 wires, and a light bulb. Electrons leave one end of the battery, go through the light bulb, where they release some energy as light, and they go back to the other end. They move in a loop. Physicists are not very good artists, so we don't really like to draw pictures like this all the time when we're doing analysis. What I'm going to do is break this down. The battery is basically a reservoir of electrons. They're moving out of one end of the battery, through the wire, into the other end, and they pass through the light bulb on the way. So I'm going to show you what this looks like in shorthand. Let me tell you what each part is. A straight line is a wire. Wires are substances with very low resistance, and we imagine them as being electron highways. Wires are basically things that electrons can slide through without being stopped. A resistor we represent with a big zigzaggy line. Like it would be difficult for somebody to do this. If you were sprinting in a straight line, but then all of a sudden you had to run from left to right, like through a bunch of cones, it would slow you down. So that's why a resistor is a zigzaggy line. Resistors are things that make it difficult for electrons to move through them. Really, the idea is that wires have no resistance, that's a simplification, but resistors have some resistance, and it's hard for the electrons to get through. Finally, this weird double line is a battery. Batteries are sources of electrons, and they also create electric fields in the wire, which makes the electricity move. It's where the electrons end up when they're done moving. So the big end is the positive side, and the little end is the negative side of a battery. So when you look at this, if you remember what I told you, you should think this right here, this right here, that's a battery. This thing down here, it's some resistor, something taking the energy away, slowing down the electrons. And these things are just wires. It would look like this. You have a battery at the top, wires all around, and then something at the bottom that's slowing the electrons down, maybe taking their energy away. So this right here and this right here, they represent the same scenario. You have a battery at the top, something taking energy away from the electrons at the bottom, and wires connecting them. One last thing. This is the last thing. History's kind of stupid. In reality, electrons move out of the negative end of the battery. They go through, and they end up at the positive end. Because electrons are negative, so they come from the negative end of the battery. Like this. They would be moving counterclockwise through this particular circuit. But, for historical reasons, we pretend like there are positive charges. We pretend like there are positive charges moving out of here, and then going into the negative end. It doesn't really matter, as long as you remember the electrons move in a loop. But we call this conventional current. People didn't really understand how electricity worked, and they just assumed that you had these positive particles moving around, when in reality the negative electrons are the ones that are moving. Okay, so that's it. We're going to get more practice with that later, but I hope it was helpful.